In the 1980s, the world faced a huge problem. There was a rapidly expanding hole in the ozone layer. So what happened? And is it still there? Let's go back to the beginning. The sun makes life on Earth possible, but too much exposure to its UV radiation damages plant and animal DNA. Thankfully, about 98% of that radiation is absorbed by ozone molecules dispersed in the stratosphere, which are continuously broken apart and reformed in this process, maintaining a delicate equilibrium. But in the early 1970s, two chemists, Mario Molina and Sherwood Rowland, demonstrated that widely used chemicals called chlorofluorocarbons, or CFCs, could upset this balance. CFCs were developed in the 1920s by three US-based corporations as coolants for refrigerators. Unlike existing alternatives such as ammonia or methyl chloride, CFCs were non-flammable and non-toxic, meaning they wouldn't burst into flames or cause deadly gas leaks. They also made great propellants, foaming agents, and fire retardants. CFCs soon found their way into a variety of everyday items and became a multi-billion-dollar per year industry. In the lower atmosphere, CFCs don't break down or react with other molecules, but Molina and Rowland showed that in the stratosphere, they're broken apart by UV light, releasing chlorine atoms. These then react with ozone, destroying it faster than it can be replenished. A single chlorine atom can destroy thousands of ozone molecules before finally reacting with something else and forming a stable molecule. Seeing the threat to their bottom line, CFC producers pushed back to discredit the scientists, even accusing them of working for the KGB. Initial estimates showed that within 60 years, CFCs could reduce ozone concentrations by 7%. But by 1985, it became clear that ozone depletion, especially over Antarctica, was happening much faster. Here, the extremely cold temperatures and unique structure of Antarctic clouds accelerated ozone loss. Scientists stationed in Antarctica noticed a massive drop in overhead ozone occurring every spring. Satellite data revealed the vast extent of these losses, and chemical tests confirmed that the cause was unquestionably CFCs. NASA soon released visualizations which were broadcast around the world and captured public attention. If ozone depletion continued, rates of skin cancer would skyrocket. Photosynthesis would be impaired, making plants, including rice, wheat, and corn, less productive and more susceptible to disease. Global agricultural production would plummet, and entire ecosystems would collapse. But many politicians, weighing immediate economic concerns over long-term ones, disagreed about what to do. The fight to ban CFCs found two unlikely allies in US President Ronald Reagan and UK Prime Minister Margaret Thatcher. Despite their general opposition to government regulation, Reagan, who had undergone treatment for skin cancer, and Thatcher, who was trained as a chemist, recognized the need for immediate action. The US and UK, along with Canada, Norway, Sweden, and Finland, led calls for an international ban on CFCs. In 1987, representatives signed the Montreal Protocol, requiring the rapid phasing out of CFCs and creating a fund to assist Global South countries in obtaining affordable, non-ozone depleting alternatives. It was later ratified by every country on Earth, the only treaty in history to achieve this. In 1995, Molina, Rowland, and their Dutch colleague Paul Crutzen were jointly awarded the Nobel Prize in Chemistry. As the use of CFCs declined, the ozone hole began shrinking and is predicted to disappear entirely by 2070. But we're not out of the woods yet. While the ban was a win for the climate, as CFCs are potent greenhouse gases, the alternatives that replace them, hydrofluorocarbons, or HFCs, are too. While generally less potent than CFCs, HFCs still trap more heat than carbon dioxide and are contributing to climate change. To address this, in 2016, the Kigali Amendment was added to the Montreal Protocol, calling for an 85% cut in global HFCs by 2047. This alone could avoid up to 0.5 degrees Celsius of global warming by the end of the century. Today, as we face the existential threat of climate change, the Montreal Protocol serves as a model for the decisive global cooperation we need to combat it. The question is, what will it take for us to come together again?